tell others also to join because we are starting today with vector integration. And it's important topic. Okay, so now there are 20 students. So we will start with this session. So today we are moving ahead with vector integration. Vector integration. Now today's tute will be, it is already scheduled and two tutes are there. So I have scheduled that 5, 6 earlier assignment. That particular written assignment is also there and the quiz is there. Okay, so it's a part of tutorial only, but then you try to solve. There are 20 questions given. There won't be any mess like last time. Now it is sorted out. Okay, so you will be able to find it out only one option, separate options. Okay, so now moving ahead with this vector integration today. So what we are going to understand from this integration. So here I have say consider some vector point function, say f bar, and now that vector point function is defined in some region of the space. So we'll consider some smooth curve, say C in that region, and some point P which is lies on the curve, correct? And there that at that point the f bar is acting. F bar is acting on the curve. F bar is acting on the curve. Then what is the integration? So I have some curve like this, and then you are just talking about this a smooth curve. Okay, C. And here I have this function for this is f bar of xyz. So that is a function given. This is some point P of r bar where the force is acting on this, correct? So f bar is acting, then in that case, the line integral is defined as, line integral over the curve C, of this f bar dot dr bar. Okay, it gives you a scalar quantity here, and that value is nothing but actually we are taking a tangent, and then that tangent, once you solve it ahead, you will get that it is converted in terms of the dot product between the tangent and that at that point the force which is acting. So the dot product of these two gives you that work done, and therefore this is given by using the derivation. It is comes to the conclusion as this is nothing but the integration, single integration f bar dot dr bar, f bar dot dr bar, where what is f bar? F bar is written as a f1 I bar plus f2 j bar plus f3 k bar plus f3 k bar, and dr bar is nothing but your dxi bar plus dyj bar plus dzk bar. Then in that case, this line integral over the curve C f bar dot dr bar is nothing but, this integral is nothing but, it can be written as multiply, take the dot product of this two. So we get this as f1 dx plus f2 dy, correct? Plus f3 dz, f3 dz. So for this, let us understand the procedure of doing this calculation, and that is very easy to do it. In some cases, you must know the transformation into polar form, as I said earlier. So please take it down the points, okay, the problems based on that. So let us take the first problem here. So consider f bar is, take the first example. Consider f bar is, f bar in this case is xy x square I bar plus xyz bar, x square I bar plus xyz bar, xyz bar. Okay, so we have to find it out here, the line integral for f bar dot dr bar for the two different cases. One is the curve, along the curve y square equal to x joining to the point 0, 0 and 1, 1, and secondly y equal to x, secondly y equal to x. So the question is, evaluate here the line integral f bar dot dr bar over the curve C. With the first question is along y is equal to x square joining 0, 0 and 1, 1, and secondly along a straight line, along a straight line joining these points from 0, 0 to 1, 1, correct? 0, 0 to 1, 1. So what I have is, I have here f bar as a function of x and y in this case, correct? F bar is a function of x and y in this case. So we are evaluating here the line integral. Line integral is I is equal to integral over the curve C f bar dot dr bar, correct? So what is dr bar? It is dxi bar plus dyj bar plus dzk bar. Now you can see a nice thing in this case, that this function is a function of x and y. So there is no z component in this case. So this curve is lies on the in the x or y plane. Okay, so that is the thing here. So what is f bar dot dr bar in this case? It is nothing but over the curve C. This is x square dx. In place of I, you put it as dx. In place of j, you put it as dy. Okay, you put it as dy. I hope that you all are with me. Okay. Once you understand the concept, it is very easy to perform in the paper itself. Okay. So what I have the first one, the first example for this is along the curve. The curve is given. It is what? Parabolic curve. You can see that y equal to x square or y square equal to x. This is a parabola. This is a parabola. So the parabola is joining to the points 0, 0 and 1, 1. Okay. 0, 0 and 1, 1. So let us move ahead. So I have the integration which I have to calculate is x square dx plus xy dy. So the first question is along y equal to x square joining joining 0, 0 and 1, 1. Correct? So I call this as point A and this as point B. And now we'll draw the diagram here. We'll draw the diagram here. So we have this is x-axis and y-axis, and y equal to x square means it is a even power of x, means it is symmetric about y-axis. Correct? So we have the curve will be look like this. This is our y equal to x square. The point 0, 0, the point 0, 0 is somewhere here. Correct? This is the point A, and the point B is say 1, 1. And the curve is this. Correct? This is your curve. This is your curve. Joining to the point 0, 0 to 1, 1. So what we have to do is we have to take that curve. Okay, we have to take that curve. So along this AB, x square dx plus xy dy. Now what we do is, where see, can you integrate this if even if I just take the integration separately, x square dx plus xy dy. Now you can see that in the first case, yes, I can find it out the integration because it is in the form of x square, correct? It's a function of x and we are integrating it with respect to x. But in the second case, you can see that it is xy dy. So there are two variables involved, correct? X as well as y. So we can't keep y as constant, or we can't keep x as constant, correct? So here what we do is we always convert the given thing in terms of single variable. We always convert the given thing in terms of single variable. So don't consider this. So what we'll do is we'll take here substitute put y equal to x square in this case. So when you put y equal to x square, what is your dy? Dy is 2x dx, correct? And what are the limits? The limits are will be with respect to x in terms of x. So what I have to do is I have to write it down this integration over the curve C, put y as x square. So it is x square dx, the first part as it is. Second, in place of y, I put x square, and dy in place of that will put 2x dx, correct? So what is this? So this integral is nothing but x square dx plus 2 times x raised to 4 dx. That is, it is x square plus 2x raised to 4 dx. Now we have to decide the limits. See, it is now the limits for x-axis. So you are now transforming it. You are transforming this to x-axis. So you can see that it is transforming to x-axis. The point here is what? 1, 0, 1, 0. So what I have to do? I have to just move. Okay, I have to just move from a, from that is x-axis value will be from 0 to 1 because y value is 0 only. See, you are taking the projection of that on x-axis. That's the meaning, correct? So here the limits of x will be from 0 to 1 everywhere, correct? We are projecting it on x-axis. Yes, so everywhere the limits will be from 0 to 1. 0 to 1. So that gives the, take the integral of this. What is the integral of x square? It is x cubed by 3. And the integral of this is what? X raised to pi by 5. Put the limits from 0 to 1. Once you put it, so here it is 1 by 3 plus 2 by 5. So, and at 0 it is 0 only, correct? So it is 5 plus 3 to the 6 divided by 15, that is 11 by 15. So the answer in this case is what? 11 by 15, correct? The answer in this case is what? 11 by 15. Now exactly in the similar way, we'll do it for the second one. Exactly in the similar way, we will do it for the second one. So take it down this, then we'll go for ahead. For the second is what? It's a line, straight line. joining to these 2 points, correct? It's a straight line joining to these 2 points. Okay. So now we'll calculate it for the second one. We'll calculate it for the second one here. So for y equal to x, the second one is what? We have to do it for along the straight line joining to 0, 0 and 1, 1. So we move ahead, we take it for second one along a straight line joining 0, 0 and 1, 1. So we have to draw a graph. Okay, once you have a graph, it's quite easy to understand. So the line is what? Y equal to x. They have mentioned that. So y equal to x is a line passing through this. We have the 2 points here. The point is A is 0, 0 and B in this case is 1, 1. And this is the direction. Okay, this is the direction from 0, 0 towards 1, 1. Correct? In vector integration, we can consider the direction also. So that is the fruitful thing. Okay. What we have to do is we have to take f bar dot dr bar and that value of the curve is x square dx plus xy dy. Now what we do is we substitute in this case y equal to x. Okay. So put y equal to x. What it will give me? Dy equal to dx. Dy equal to dx. Substitute it. So we get x square dx plus x into, in place of y also you are putting x. This is dx. So we'll get this as x square plus x square, that is 2x square dx. Now we have to decide the limit. So you can see that this is converted in terms of x. So we take a perpendicular, that means it is projection on x-axis. So this value is 1, 0, correct? So this is the direction. So what I have to do is I have to take 0 to 1. These are the limits. These are the limits. So here x is varies from 0 to 1. Correct? And now you calculate this integration. So we get this as 2 times x cubed by 3 from 0 to 1, that is 2 by 3. So what was the answer earlier? The answer was 11 by 15. And the second answer was 2 by 3. Correct? Second answer was 2 by 3. So that both the answers along different curves, I am getting different answers. Correct? Different line integration for the same vector point function. For the same vector point function. Correct? Now, I'll just change a small change in our vector field. So instead of x square I bar plus xyz bar, we will take the another example. So evaluate this line integral f bar dot dr bar, where f bar is say x square x square I bar plus y square z bar. Okay. And I'll keep the same questions. Okay. So the first one is what? Along y equal to x square, joining 0 0. So the point A is 0 0 and B is 1 1. Okay. And the second one is along y equal to x, the straight line joining to the same. Is over the curve C. Vertical this point, this the diagrammatical representation is exactly same. So I just substitute here, put y equal to x square here. So what we get? dy equal to 2x dx. And then this integral will be what? X square dx plus y square means what? X square square. So x raised to 4 into 2x dx. And the limit C, if you take a perpendicular, this intersects at 1 0. So the limits are from 0 to 1. So we get this integral from 0 to 1 of x square plus 2 times x raised to 5 dx. And once I solve this is x cubed by 3 and this is 2 times x raised to 6 by 6 from 0 to 1. So you can see that 2 by 6 is 1 by 3 only. So we get 1 by 3 plus 1 by 3, that is 2 by 3 as answer, correct? This is in first case. Now for the second one, we are taking the curve as y equal to x. So we'll substitute y as x. So dy will be what? Dx. So this integral will be what? It is x square dx plus y square dy. Substitute here y equal to x. So I get x square dx plus x square dx, correct? And again the limits are from 0 to 1 only. So we have this line is y equal to x. The points here is 0 0 to 1 1. Take a perpendicular here. It is converted to this, correct? So the limits are from 0 to 1. Once you solve this is 2x square dx from 0 to 1 and you'll get the limits as, substitute the limits here and we get the answer as same. See, the miracle has happened, correct? In earlier case, if you just observe that we are getting along different curves, we are getting different answers. But here you can see that along any curve, along any path, we are getting the same answer. Okay. Why it is so? Why it is so? So we'll observe the condition now. Okay. We'll observe this both the vector point functions now. I hope that you have done up till this. So what is our f bar in the first case? You see, f bar in the first case was given as x square I bar plus xyz bar. Now if you find it out that del cross f bar here, so this is Ijk, I have dabba by dabba x, dabba by dabba y, dabba by dabba z, here x square, xy, 0. Find out this, so it is I bar times, this is 0 minus a bar times it is y, correct? Sorry, it is 0 and plus k bar times will have your y, correct? So this is non-zero. In second case, f bar is given as x square I bar plus y square z bar. Correct? So what is our del cross f bar? It is when you take double by double x, double by double y, and double by double z with this x square, y square, and 0. So you'll find it out that it is I bar times 0. J bar times is also 0. And plus k bar times we have here 0. So it is 0. So f bar is irrotational. Since it is irrotational, that means it is conservative. Correct? And what we have seen yesterday, that we are writing f bar in terms of del phi, and I can find it out the scalar potential, correct? Scalar potential phi. That means what? It depends on the function phi, irrespective of, that means the starting and the ending point, correct? Scalar potential irrotational means what? It is not signifies the rotation. That means it will not give you the direction. It depends on only the starting and the ending point. Okay, so because of this you'll find it out that the answer in the second case, second f bar, they are all same. They are independent of the path which we choose it from the starting and the ending point. Whereas in the first case, since it was not irrotational, okay, it was not irrotational, because of that we are getting along every path different answers. Okay, we are getting along every path different answers. So you have to remember this is a very important thing. Okay, very important thing here. So you can just write it down that so in the first case you just note it down. In the first case since f bar was not irrotational, and you can see that you can immediately find it out the answer just by observing that we can write it down this x square I bar plus y square z bar as a total derivative, correct, of some function. So that observation is important here once you start solving the problems. That will help you out. So here, when in the first case, f bar is not irrotational. F bar is not irrotational. So we can see that the line integral depends on the path chosen from chosen for the terminal vertices. Correct. Now you have understood terminal vertices means what, because you have done the graph theory part earlier. Correct, in discrete mathematics. So between the terminal vertices. In the second case, f bar is irrotational or conservative. F bar is irrotational or conservative. Therefore, f bar can be written as del phi. Correct? F bar is equal to del phi. And we can find it out the scalar potential phi in this case. Scalar potential phi in this case, and hence you can say that f bar is independent of the line integral f bar dot dr bar is independent of the path chosen, independent of the path chosen for the terminal vertices, for the terminal vertices. So here it can be a closed curve or it can be open curve. Okay. So in both the cases, you will be able to find it out the line integral when we have the conservative force field. Okay. Whenever we have the conservative force field. Correct? So now moving ahead, moving ahead, we take the examples. We take the examples here. Some more examples here. So take the first example. Take the first example. Evaluate the line integral. Evaluate line integral f bar dot dr bar, where f bar is written as f bar is written as 3x square I bar plus 2xz minus y times z bar plus z square y times k bar, z square y times k bar along the straight line, along a straight line joining 0 0 0 and 2 1 3, line joining to this 2 point 0 0 0 and 2 1 3. Especially I have taken this problem because uh, earlier I think you have seen the symmetric form of equation of line in your geometry for part. Okay, so this note is important here. So symmetric form of equation of line. Equation of line. This is a note. Okay, important note. So if a line is passing through two points x1 y1 z1 and the point B. Now you are talking about three-dimensional plane. Okay, because whenever you have seen that earlier in two-dimensional geometry in 12th standard or in diploma also, you have seen this, that you can write it down the equation of line by using 2-point form. Right? So that we have generalized, and that form is nothing but your symmetric form of equation of line. So the equation of line L is written as x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1, that is equal to z minus z1 upon z2 minus z1. Okay, so this equation is called a symmetric form of equation of line. Symmetric form of equation of line. So what I have here, I have this as x1, y1, z1. This is x2, y2, z2. Correct? So the first task is we'll write it down the equation of straight line. Okay. The equation of line, straight line. Of course, we are using it if it is the word is mentioned, straight line word. If it is mentioned, then only you are supposed to use this, otherwise not, because otherwise we don't know what path is chosen between the 2 points. Correct? So it is what? X minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. Substitute the values. So it is x minus 0 upon 2 minus 0, y minus 0 upon 1 minus 0, z minus 0 upon 3 minus 0. Now equate it, since they are in proportion, we'll equate it to some proportionality constant, say t. Okay. Then what I get this as? So x by 2 equal to t. X upon 2 equal to t. So equate it this. Okay. So x by 2 equal to t means x is equal to 2t. Then y is equal to 1 times t and z is equal to 3t. Okay, z is equal to 3t. So we are going to substitute in that line integration this values of x, y, z in terms of a parameter t. Okay, so what I do is I just take this line integral f bar dot dr bar. What we do is we integrate it and replace this Isaac by dx dy dz. Okay, that way you can remember. So this is 3x square dx. Second term is 2xz minus y times dy. And third term is z square y dz. Correct. So here I am putting now in place of x this 2t. Correct. So what is your dx dy dz? So dx is 2t means 2 dt. Dy is going to be dt only. And dz is what? 3t is 3 dt. Correct. So substitute that. So this integration is now becomes 3x square. So 3 times 2t bracket square into dx is what? 2 dt. Correct? Plus next term is what? 2xz. So 2 times 2t into z is what? 3t minus y. Y is what? t. Okay, times dy. Dy is what? dt. And z square y. Z square means 3t square. So it is 9t square into z square y. So 9t square into t. And then dz. Dz is what? 3 dt. Correct. So here you require little bit patience for solving this. Now, what I have to do is I have to decide the limits of t. Correct. I have to decide the limits of t. So the limits of x, y, z is given. So x, y, z, that is how you write this x, y, z. They are nothing but 2t, t, and 3t. Correct? 2t, t, and 3t. So this x, y, z is moving from 0, 0, 0 to this point, 2, 1, 3. Correct? 2, 1, 3. So what will be the value of t to get this answer? See, what is x, y, z? X, y, z, we are writing it as what? It is 2t, t, and 3t. So at what value of t I'll get the first point when I put t as 0. See, when you put t as 0, you get the first point as 0, 0, 0. Now at which value of t you get the second coordinate, second point 2, 1, 3. 2, 1, 3, you will get it from this 2t, t, and 3t when you put t as 1. So the limits of t will be decided here and they are from 0 to 1. These are the limits of t. Okay, so many a times you will find it out that the limits of t are going to be 0 to 1. In some cases, it is like 0 to or minus 1 to 0, 0 to half, okay, or 1 to 2, like that. Now, based on the situation, of course. But then I think now you have understood here, so how you have decided the limits. That is very important part. Now, what you do is you solve this integration. You know now how to solve this, correct? So this is what? This is integral 0 to 1. You collect the terms containing t, take out dt outside. So this is 4t square. 4 3s are 12, 12 2s are 24. So 24t square. Then the second term is what? It is 4t. 4 3s are 12. So 12t square minus t times dt. And the third term is what? 9 3s are 27. So 27t cube. And this bracket times dt. Correct? So you just find it out the 24 plus 12, 36t square, correct? So this is 36t square when I add it. So 36 times t square, so it becomes t cube by 3, then minus t square by 2, and then 27 t raised to 4 by 4, correct? Put the limits from 0 to 1. So we get this as 36 by 3 minus half plus 27 by 4. So calculate this. Okay, so 12 minus half plus 27 by 4 and get the answer. Okay, so all of you have understood this. This is a very important part. This is very important part here to get the answer. So whenever we have a straight line, earlier we have taken a straight line which was given as y equal to x. So we have substituted that y equal to x in the integration and we converted everything in terms of x. So that is nothing but the projection on the x-axis and we got the answer. Now in this case, since the points are given in 3 dimensions, correct? They are having, these are 3 tuple where the x, y and z coordinate is also involved. And there they ask the straight line joining to the points, 2 points here. So that means you have to write it down this in symmetric form. Okay. So the symmetric form of equation of line is given to you. Then you just equate it to some proportionality constant, say t, convert everything in terms of t. So x, y, z is getting replaced by t, correct terms in t in the integration. So you will find it out that the integration is completely in terms of t. Now we have to find it out the limits of t. So for that, what you do is you have to just observe the points. Okay, the points are from 0, 0, 0 to 2, 1, 3. Now for which value of t, once you convert that x, y, z in terms of t, for which value of t it will satisfy the first point. So that is your initial limit. Then if it's you have to calculate the value of t for which it satisfies, or you get the second coordinate, second point coordinate. So that is the final limit for t, and that way you will get the answer. Okay, I hope you all have understood this.
Can you explain the limit again? No.
Okay. So now we'll write it down for the last one more problem, and then we'll do the same thing in tomorrow's session. So I'll give you the question here. The nice questions are there. Let me search for the question where we are using the conservativeness, correct? So the force field is conservative, and there we are using a different technique for solving purpose. There are ample of questions given now. In the paper, of course, you will have the questions where directly they will provide you the limits, okay, or the values x, y, and z in terms of t that is given. You have to find it out on your own, the limits. And the F bar is so simple that you will be able to do that part in 2 minutes, correct? So that way, but then definitely there you need to keep a timings, correct? Because otherwise it is not that easy to solve the things, correct? In time. Of course, the problems are easy. Problems are easy. So as I said, it is simple. You'll be able to find it out that, but okay. So let me take a problem where we have seen the conservative force field there. So in case of conservative force field, so just put a remark here. In case of conservative force field, it is we have del cross F bar is 0, correct? F bar is 0. So we are taking F bar as del phi in that case. Then the line integral from A to B of F bar dot dr bar is nothing but the line integral from A to B of, we have seen that it is del phi dot dr bar. What is del phi dot dr bar? See, in earlier when we have seen the derivation for that rotational and conservative force field, del phi is for dabba phi by dabba x times dx, correct? And then that is nothing but your d phi, if you remember that. So we have here d phi from A to B, and that is nothing but the integral is phi from A to B, which is phi b minus phi a. That means it uh, depends on the value of the starting and the ending point, which I've told you earlier, correct? Now, in case of closed curve, in case of closed curve C, okay, this is for the open curve, correct? In case of closed curve, what will happen? The line integral for the closed curve, how you write it down, that is nothing but we just draw a small circle, okay, on the integration. Single integration, draw a small circle, and that is nothing but for the closed curve. Okay, so this is closed curve. So F bar dot dr bar on the closed curve. So here again, the function is, this vector field is conservative. So F bar is written in terms of del phi. So I'll get this as del phi dot dr bar. And what is this over the closed curve C? So that means if I have a curve like this, okay, so the starting point is A. And again, we are coming back to A, no? So this is your the integration from A to A of d phi. And what is this? It is phi from A to A, and that is 0. Okay. So when you have the conservative force field, then in that case, the line integral is, you'll get it as 0 in this case. Okay. So many a times they ask the question that whether the work done is conservative. Okay. So work done is whether the find the work done, find work done. Work done is nothing but the line integral F bar dot dr bar. And when it is conservative, the work done is conservative. Conservative if this line integral F bar dot dr bar. Now that is for the closed curve. Huh? Please remember this. This is for the closed curve. So when it is 0. For the open curve, that value has to be equal to the value of phi from A to B, correct? Along any curve. So that is nothing but your, but then the work done is conservative for the closed curve if the line integral F bar dot dr bar is 0. F bar dot dr bar is 0. So that is the important thing here. Okay. Now, can you tell me your tomorrow schedule? Can anybody tell me? Do you have any lectures tomorrow? Because I am taking one combined lecture tomorrow, even if it is a holiday, but we'll have a lecture. So, yes, do you have anything in Saturday? Tomorrow is the first Saturday, no? So, anybody from you? Please tell me.
We actually don't have a schedule for Saturday, and I think first Saturday there is a holiday. I think one of the teacher was saying earlier.
Yes, it's a holiday, but then due to I want to complete some of the tasks. So as you are having your exams, no, from 11th. So I'm trying to wind it up our syllabus till 9th, maximum of the part. So that I wanted to wind it up. So for that, we'll have a session tomorrow. So tomorrow, at 11, is it okay for everyone? By the time, I think you'll get a good sleep also. Correct? Since it's a holiday. So we'll meet tomorrow at 11. I'll post it on our group also. So tomorrow we'll have a session at 11 o'clock, and that will be based on this line integral with the Green's lemma. And if possible, then we'll go ahead with the divergence. These are the two topics along with Green's theorem, and that will end with this entire unit. Okay, so today we have started with the unit. So we require 4 to 5 lectures for this. Okay, so we'll meet tomorrow at 11 on the same link. Join the same link. I'll post the message accordingly. And join for today's tutorial. So it is completely based on vectors, vector differentiation, earlier unit. So now we have completed that unit. So all the questions are based on that. And even I have shared you the notes also, the MCQs also to all, so that you'll be able to solve those and that will help you out. I'll share some more questions. I'm just taking it out. So send your attendance on our group today on WhatsApp group. Okay. So bye to everyone.
Thank you, ma'am.
Thank you, ma'am.
Yes.